Welcome to Viomology. In today's video we will understand how LHC is solving the mysteries of the universe. Let's begin. The Large Hadron Collider, or LHC, is the largest and most powerful particle accelerator in the world. Located at CERN, the European Council for Nuclear Research, in Switzerland, the LHC is a marvel of modern science. Scientists from around the world come together to study the mysteries of the universe using the LHC's incredible capabilities. The LHC is unique for its size. It's a circular tunnel that spans 27 kilometers, about 17 miles, in circumference and is buried 100 meters, about 328 feet, underground. The tunnel is lined with powerful superconducting magnets that steer beams of protons around the ring at nearly the speed of light and then smash them together. Another unique feature of the LHC is its energy. The LHC can accelerate two beams of protons in opposite directions, and then collide them at 4 different points around the tunnel. The LHC can accelerate protons to energies of up to 6.5 TeV. To put that into perspective, that's more than 7 times the energy of the previous record holder, the Tevatron at Fermilab in the United States. This high energy allows researchers to study particles at extremely small scales and probe the fundamental laws of nature. The LHC is also unique in its ability to collide particles. The LHC can produce collisions between 2 beams of protons, with each beam containing billions of particles. When these protons collide, they create a shower of subatomic particles, including ones that have never been observed before. By studying these collisions, scientists can learn about the fundamental nature of matter and the universe. The data collected by the LHC is then analyzed by scientists from around the world. This data has led to major breakthroughs in our understanding of the universe. One of the most unique features of the LHC is its detectors. There are 4 main detectors at the LHC, each designed to study different types of particles and interactions. The largest and most complex detector is the CMS, or Compact Muon Solenoid, which is nearly the size of a 5-story building and weighs over 14,000 tons. The detectors are able to record the trajectories and energies of the subatomic particles produced in the collisions, allowing researchers to reconstruct the events and make precise measurements. At each collision point, detectors capture the particles that are created in the collision. These detectors are incredibly sensitive and can measure the properties of the particles with incredible accuracy. Finally, the LHC is unique in its potential for discovery. Since its first run in 2010, the LHC has already made several groundbreaking discoveries, including the discovery of the Higgs boson, a particle that gives mass to other particles. But there's still much more to be discovered. The LHC is capable of producing exotic particles that could shed light on dark matter, antimatter, extra dimensions, and other mysteries of the universe. Perhaps the most famous discovery made by the LHC is the Higgs boson, also known as the God particle. This particle was predicted by theoretical physicists and was finally discovered in 2012 using data from the LHC. This discovery confirmed the existence of the Higgs field, which gives particles mass, and was a major milestone in particle physics. The data collected by the LHC is invaluable to scientists around the world who are working to unlock the mysteries of the universe. The Large Hadron Collider is truly one of the most incredible feats of modern science. It has revolutionized our understanding of the universe and will continue to do so for years to come. In conclusion, the Large Hadron Collider is a unique and robust machine that allows us to probe the fundamental nature of matter and the universe. Its size, energy, ability to collide particles, detectors, and potential for discovery make it a one-of-a-kind scientific instrument. We can't wait to see what new discoveries it will bring in the future. Thank you for watching. Do comment with your thoughts on what you wanted LHC to discover.